Okay. So, we will look into some of the modern construction techniques related to building, which contributes to sustainability or sustainable. As we have seen in the last class, actually we saw last time when we talked about that if you want to construct large number of houses over a short period of time, it has to be industrialized construction, right. When we are looking at affordability of house and things like that. So, it has to be, so there are different systems. So, one of the system is autoclave aerated concrete, right. This is a well known system. Then insulated precast system and insulated precast forms. So, the formwork itself is insulated. So, this technology is very much important. So, autoclave aerated concrete, insulated precast panel and insulated, this is what we will discuss. So, autoclave aerated concrete generally how you produce? Essentially the component should be, you see its purpose is that it has got very low thermal conductivity, and this is very much used in India now. There is almost, you will find the blocks have gone, there are manufacturers who produce this, and that is what it looks like. That is what it looks like, if you look at it, that is what it will look like, right. And obviously you have some fine aggregates, cement and cement plus fly ash, and generally since we have seen earlier the thermal conductivity is a function of porosity. K is a function of, K is a function of porosity, and higher the porosity, thermal conductivity is lower. So, it acts as an insulation. Therefore, we try to increase the porosity by doing what? Putting in kind of agent, expansion agent or foaming agent you can talk about. Generally people have been using aluminum powder, right. So, this is the percentage by volume. Now, this aluminum reacts with calcium hydroxide actually. So, this is, it can give to 80% porosity and factory molded, cut into precise dimensioned units actually. So, basically that is what it is. The other variety is foamed concrete. Foamed concrete will have a foaming agent. So, you pass the foam into the concrete while making it in green state, right. So, this is non autoclaved, and foaming agent you add some organic foam, synthetic foam, and that is how you get a lightweight concrete. Conductivity can be very low, 2.02 watt meter degree, watt meter Kelvin, and this is chemical expansion agent or some sort of agent which will react, for example, aluminum powder as I said, and then you have to do curing at high temperature and pressure. So, that is AAC, right. So, that is kind of a system is there. This is essentially you start from here, raw material, generally silica or quartz sand. In fact, in Delhi people were earlier using even Yamuna sand. So, or some silica or some sand, lime, water, cement, aluminum powder. So, this is what it is. So, this aluminum powder together with all this raw materials are mixed, mix the aluminum powder and put it into the mold. There will be formation of air bubbles, and this mold, in the mold you get large units which is cut into pieces. These blocks are then put into the autoclave, cured, then packing and sampling. In fact, it is almost an automated process. It is almost an automated process. You can see that this will be automated process. In fact, there will be large tray kind of thing where they will be doing this. There are a number of factories even around Delhi, these are there. So, essentially they are lightweight, generally cured for 8 to 10 hours. Blocks or panels of autoclave aerated concrete are joined with mortar, because then they are masonry units. Components can be used as wall, floors, even roof, and the lightweight material offers excellent sound and thermal insulation. So, that is what is the thing. So, it is a multi, purpose, serves the purpose of multifunctional, serves as a purpose of envelope, and then all kind of insulation. So, this is adequately strong and good fire resistance. It of course requires some finish, because otherwise it is so porous, moisture may penetrate. So, you might give a finish to it for the purpose of durability, right. So, this is the system, something like this will look like this. So, this is the this is the production system, uncured green AAC, it is here, and in centimeter scale if you look at it, right, 9 to 10 centimeters. So, the boards are of this kind of sizes, right. So, this is ready to fet, there are rails on which it goes and then autoclave to be rapidly cured. So, it can be fully automated, and so basically multifunctional, as I said. Combine the load bearing action with insulation function, also load bearing, but then generally not used for load bearing structure. In one story structure you might use one on two story. Dimensional stability, generally aluminum powder will react with calcium hydroxide producing hydrogen, and this hydrogen forms the bubbles which remains there, kind of air voids, and they give you this action. So, you can actually it all started with basically they were trying to get replacement for wood, AAC, replacement of wood long back, not today, 1925, trying to replace wood with a cementitious sort of a material which should be cut, which one can cut into shape. So, that is how actually originally it developed, added the chemical, and therefore, it can be easily saw cut like wood, lightweight, and hence reduces the structural load. Resource efficiency give it lower environmental impact in all phases of its life cycle, from the processing of raw materials to the disposal of waste. So, these are the advantages. For structural use, of course, you have to do reinforcement, right, or maybe grouting. So, in the cell, so what you will have? You will have a cell in which you will put the mortar or the grout and the reinforcement, and AEC blocks will be around there, right. So, generally supposing it is a flexural member, so you leave a concave depression, right, concave depressions along the vertical edges and can create a cylindrical core, and then between two edges. For example, you might have a panel like this and another panel like this, and then like reinforcement could be here, something like this, something of this kind. So, concave depressions along vertical edges can create a cylindrical core between two adjacent panels. So, if they are basically if it is for floors or slab, this cannot take the load. So, you have to reinforce it. So, you can create concave depressions where you put the reinforcement and that kind of thing. For other application, a vertical cell is placed at corners on either side of the openings and at 2 to 3 meter spacing along the wall. So, for walls, basically if you want to have you can have the corner. So, you can have a cell. So, you can actually innovatively put in reinforcement wherever you like by putting additional mortar or similar sort of thing, right, or grouts. So, being light, its handling is easy. In fact, possibly manually it can be handled. So, small crane, sometimes even manually, can be installed as done for masonry unit. So, interior would look something like this, can give a good finish. The panels are here, if it is panel, large size panel, and you can see that it can float. So, density is very low, right. Could be varying from 400 kg per meter cube to 1600 kg per meter cube, depending upon how much aeration you have done. So, it will depend upon that. So, you can make it lightweight, and obviously it is non-toxic. Project cost can reduce, and most importantly, as we have seen, the bricks, production is extremely inefficient, both types in terms of emissions as well as energy. This, on the other hand, is cost effective and neither of it does not generate any toxic material, no toxic gases or other substances in autoclaved aerated concrete. So, no emissions, and that is the advantages. Disadvantages: if you have to install during rainy weather, this is known to crack after installation, because moisture will penetrate, and relative moisture differential moisture condition might result in cracks. So, reducing the strength of the mortar and ensure blocks are dry during and after installation. Other thing in brick masonry system, it is actually the differential movement of the mortar and units, as we call it, masonry units, that is important for failure. Even your regular load bearing masoneries, if you look at their failure, they do not fail because brick fails under crushing or something of that kind. What happens is, Poisson's ratio of the mortar and the masonry unit is different, right, even after hardened stage. So, when you have applied load, one would try to expand more, another will try to expand less, inducing tensile stresses. So, that is one thing. Or if there is a kind of differential movement of any form, shrinkages for example, the mortar wants to shrink, the masonry does not shrink, which is already in case of any one of the, even in case of clay bricks, they are already vitrified. So, they sort of you have already they are stable condition. So, mortar, if it shrinks, it will induce a kind of stress onto the brick unit, because brick will not like to shrink. So, that is why it is important for mortar to have low shrinkage. That is why you do not use too much of cement in any kind of mortar. So, similar situations are here also. Mortar strength should be relatively low, and it should be compatible with the strength of the blocks. In fact, weak mortar is what is generally people look into, because Poisson's ratio, elastic modulus, etc., all are related to strength, empirically related to strength as we measure. So and also blocks should be dry during and after installation. Nature is obviously brittle, this should be there. So, therefore, more carefully you have to handle to avoid breakage, and brittle nature of these blocks requires longer, thinner screws if you are trying to fix in something. Because if you are trying to do nailing, for a wall, nailing property is important. So, thinner screws or nails, so that is what it is for wall hangings, and wood suitable drill bits or hammering in it. So, you can do drilling and then screw it like you do it in wood. Special large diameter wall plugs are also available, but their cost is slightly higher. So, that is one thing. Okay, generally first course will be laid and leveled, blocks are stacked together with a thin bed, mortar in a running bond with minimum 150 millimeter overlap. So, that is the construction practice. Walls are obviously should be in plumb and things like that, leveled and squared with a rubber mallet, etc. And openings and odd angles are cut with hand saw, band saw. So, saw cut, you can cut them as you wish. Reinforcement locations are determined, you can put the rebar, because if it is a flexural member, you need some rebar. and grouting can be done. Grout must be mechanically vibrated to consolidate. For example, between two panels or in a panel you have a groove and then put the reinforcement, put the grout and vibrate it, that is what it is. Bond beams are placed at the top of the wall and can be used for heavy duty fixture attachment. If you have wall, put a beam and then this system. All right. A continuous bond beam is created at the top either with plywood or AEC material with bond beam block, and openings can also be put in this sort of wall form. So, put pre-cut or field cut, whichever way you like. That means field cut means you will have to cut with the hacksaws. So, roof frame and framing is connected to the conventional top plate or hurricane steps embedded in the bond beam. So, floor framing is attached to the standard ledges anchored to the side of the ASC assembly adjacent to the bond beam. ASC floor system bear directly on top of ASC wall. So, you can have, but you can't go very high rise. This will be for low rise building, it can completely replace. This is not precast system except for the, if the wall I have made it fully precast, which usually is the blocks, and blocks are then formed like mortar. So, the space of construction is not very high like precast system, which we will discuss a little bit later. Okay. Larger structural steel members are set on weld plates, bolt plates to connection, and obviously as I said, it is now quite popular in India, you find, but they are used as largely now used as sort of infills, not necessarily for structural purpose, but for infills and commercially there are number of them are produced. So, this is quite popular. Now, properties, if you look at it, density as I said varies from 450 to even 1600, but let us see 450 to 750. The compressive strength will be 3.2 MPa, which is lower class brick actually, right, and this is somewhat better form of the bricks. So, as density increases, strength increases, this we can understand very easily, and flexural strength would be proportional. So, they it's roughly around, if you can see, it's around 5% of this one, So, approximately you get 5 or 7, 10% even, 10 flexural strength is usually 7-8% of the compressive strength for any of such materials. Any such material, flexural strength is about, tensile strength will be even lower, direct tensile strength. So, this flexural strength, and if you see E values, they are of this order, but what is the most important thing is this part. Thermal conductivities are quite low. Some of them with say much lower density with foam concrete can go even less than this. So, they are of this order, while normal concrete bricks we have seen is of the order of around 0.7, 0.8, and bricks, clay bricks 0.7, 0.8, and density being low, even if you are using them as infill, actually they will reduce down your structural dimension of structural system, right, because the load would be much less. So, they reduce down the load onto the structural system itself. So, that advantage you get, in fact, it would give you overall cost saving. The codes, of course, BSEN, these ones are there. So, European codes, these are available in details. Now, this you remember, I talked about the thermal conductivity part. ASC stands somewhere there in case of dry state and in case of saturated state, somewhere here porosity can go as good as 80% and so on. So, foam concrete, or AEC block, the thermal conductivities are much lower. So, that is one of the biggest advantage, and you can combine together. Economics, life cycle cost will be lower. Usually production cost is higher, because you have to have a mechanized system to produce this. So, if you have low volume of production, then obviously cost would be, if you have low volume of production, cost would be higher, because you have to get, initial investment is higher. So, break even, there is a break even number. after certain volume of construction, cost reduces. Sometime later on I might talk about break even number related to this. What we mean to say is, as you see, unit material cost and unit labor cost is much less, but you have an initial investment compared to other form. So, but you have an initial investment. So, as if I calculate all of them together using engineering principle, economics principle, per unit cost will be lower as the number increases. So, typically the curves are something like this: is a n initial cost for 0, you will have some initial cost, then it increases in this manner, and beyond a point of course, it starts again increasing. But if you have cast in other options, the other kind of system where they are 0 to start with, because they are not you do not have any investment involved, cast in situ sort of system, or big of course kiln you will have some investment as well. So, you will find that beyond this point this is cheaper. Beyond certain point again, even the precast system or similar sort of system tend to increase the cost if you go beyond their capacity, because you have to put in more resources in terms of equipment and labor to produce higher. So, therefore, that is why the curve is sometime non-linear. So, basically life cycle cost will be lower, production cost is higher for low volume of production, but cost reduces as you increase the volume of production. So, this is what shows transportation cost is lower. So, you can see that when you talk of sustainability, which we talked earlier, it would fit in pretty well, because transportation in the embodied energy, transportation was also a part. Since it is lightweight, transportation cost per unit volume would be also lower, and both production and transportation cost have implication on initial cost of course, right. So, that is what it is. Okay. Quicker construction, hence likely to fetch early return with much lower workforce and equipment, because you can finish the job earlier, right. Reduced finished material cost, quicker application and finishes. Most important is of course reduction in operational energy in case of a conditioned building. So, life cycle cost would be obviously lower. So, this kind of technology do help, because this I think I have shown you already. So, this already I showed you. So, this is what it is. So, this kind of material, they have their advantage. In fact, some places you may not get in fact clay bricks these days. For example, Hyderabad, the quality of clay is so bad, so they have not been producing, but then they were not necessarily using AAC, using some sort of block, but AAC has got real good advantage in terms of that. Okay. Insulated wall panels, sandwich wall panels, this is other kind of thing. Now, basically last class sometime I was mentioning that in precast system you can have linear elements. That would be individual beams, columns, which I will not discuss here, etc. And slab would be always planar. Slab would be a planar element. Now, these ones are joined together to form the portal or frame, right. Now, as opposed to this planar system, planar elements as we call them, planar element, which is 2-dimensional. So, I can have wall as well as slabs of the same, and I think I must have shown you hollow core slab last class, or if I have not shown I will just come to that maybe. Basically these are called planar elements. So, these planar elements they can combine, they can be multifunctional. So, for example, in this one a sandwich panel sandwich panel will have two leaves, outer leaf and the inner leaf and an insulation material in between. Now, purpose of this, purpose of this, so purpose of this, an insulated precast concrete wall sandwich wall panel is a precast concrete wall panel with two layers of concrete separated by a layer of rigid insulation. Now, just I will come to this, but consider this sort of a thing. Let us say their purpose normally would be to take the local wind loads. Wall are supposed to take local wind loads, right, if it is in low rise building. I mean, sorry, if it is in a framed construction. But supposing wall themselves is a part of the integrated part of the system, that means you have a wall and that is connected to the slab. So, you have to make it 3 dimensional, then this should act together. Now, in all cases, I have got a small leaf here, I have got a small leaf here and there is another leaf, right, I have got another leaf, and if it is flexural loading, if it is flexural loading, let us say flexural loading, as we know, if I look at the strain diagram, of course, they will look like this. Strain diagram will be would look like this, because the top layer moves as it bends, top layer moves, bottom layer moves, and there is a compatibility of movement. So, therefore, strain diagram would be something like this, but the stress diagram, if I look at it, it would be something of this kind. Stress diagram would be something of this kind. This would take, I can neglect this portion. So, this is, let us say, tension and this is compression. So, this zone, and I can just simply neglect their effect, they are only causing shear transfer. So, shear diagram, of course, you will have something like this, So, because the material will, top material, will slide over the next layer of material since it is bending. So, that shear force has to be transferred from the top layer to the middle and middle to the bottom, and as we know, bending shear is maximum at the. So, this in between core allows, through shear developing shear stresses, allows transfer of load from top to the bottom, and it allows, because it will resist the sliding of the top one and then so on so forth and bottom again. So, this bending, so the core does not have to take the flexural tensile stresses nor the compression. So, I can model it in this manner, two rectangular stress blocks, and that is actually how it behaves. There will be, of course, there will be some amount of stresses in this one also, but I am not worried. So, these materials are stronger, the leaves are stronger, they carry the load, but this I can make a little bit weaker, but they can provide thermal insulation. So, that is how it looks like. So, you have a outer leaf, maybe inner leaf finishing, and then you have kind of a material and which are bonded, connected also. So, that is what a sandwich construction looks like, that is what a sandwich construction, two layers of concrete, often referred to as concrete widths, leaves basically they are connected by one of the width connecting system, which could be any kind of for example, polyurethane foam or similar sort of thing, right. So, the concrete can vary in thickness depending on structural load requirement and architectural requirements of the project. So, generally thickness range from 60 to 150 mm. That means, you will have about 150 mm thick concrete, and it can be all precast, it can be all precast, and there is a in between insulating material, right. So, this thickness of this one will depend upon the flexural load carrying capacity, because they are the one which carries the flexural load, as I showed through the stress block, they are the one. So, the concrete carries the flexural load, the shear transfer takes place through the core and which also acts as an insulation. So, it is a multifunctional system and can do expanded polystyrene or polyurethane foam. This is thermocol, as you know, something of the similar kind you can have, and this is what this can make it a multifunctional system. So, insulated wall panels are pre-engineered and custom manufactured off-site and delivered directly to the job site for installation right on time. Project cost, it will reduce, obviously not toxic, right, it does not produce anything, and multifunctional. So, advantage is multifunctional, right, and can combine load bearing action with insulation function. Therefore, operational energy consumption will be much less. So, dimensional accuracy of course you require, it has to be, since it has to be better engineered. Thermal efficiency, obviously K of the foam material will be 0.03 to 0.04, you can decide on that. Conductivity of the core you can decide, hence you can have low U value. And quality control in manufacturing, and if you remember we can have time lag, maybe I have mentioned sometime phase time lag, because whatever heat comes from outside it will be stored and sent inside later on, particularly good in desert type of climate. So, you can design the system for thermal efficiency and minimum energy consumption, right. So, this is what we call amplitude decrement or damping. So, you can get amplitude decrement in the amplitude of the temperature wave, because this is time of the day, this temperature. So, inside temperature, outside temperature, there will be a time phase lag and there will be a amplitude decrement as well. So, I can design this system to get right kind of U value and right kind of time lag and decrement if I want, because in case of warm humid climate I may not need that much of time lag, while in case of desert type of climate I might need good lot of time lag, because diurnal variation of temperature is very high and I can design the system, custom design it. Obviously, speed of construction will be very high, because parallel system precast. And economics, life cycle cost is obviously lower, production cost is higher, same, low volume for low volume production, but per unit cost reduces with increase in volume of production. So, lightweight can be lower transportation. Besides that, you see overall building mass would reduce. If you are using the wall effectively for load bearing situation, earlier what I mean to say, in case of a framed building, the walls actually do not carry the load, but even in a not very high rise building, even in low rise, moderately rise building, if you are able to take, if you are able to make the wall load carrying, then overall material cost would, material consumption would reduce, and therefore it makes it sustainable. Lower transportation cost and same as I said earlier. Same, quicker construction and reduced finished material and life cycle cost will be lower, and this is the same thing. So, next we will look into insulated concrete form. This is a formwork which is insulated. We will look into this in the next.